Welcome to Maths for All. I'm Aisling Flynn. This is measure 1.2 perimeter. Perimeter is given the letter L. To measure the perimeter of a shape is to measure the length around the outside of the shape. It is one-dimensional or 1D, and it is measured in meters, centimeters, millimeters, etc. And to calculate the perimeter of a shape, we add the individual lengths of all of the sides of the shape. So, for example, this shape here, to find its perimeter is to find how many units it takes to walk all around the outside of the shape, add the individual sides, and the answer in this case is 27. Quadrilaterals. Well, quadrilaterals are four-sided shapes such as squares. Points of information: all four sides of a square are equal. So to calculate the perimeter, you just need to know one of those sides. In this case, the sides of this square are 9. So, and 4 9s are 36. That gives the perimeter. Opposite sides of rectangles are equal. So in this case, the right is 5, so left will also be 5. Top is 12, so bottom will also be 12. To find the perimeter, you will add 2 12s and 2 5s, and you will get 34. Similarly, opposite sides of parallelograms are equal. Of course, the rectangle is also a parallelogram. In this case, you have two sides. The slope sides are both 6, and the horizontal sides, the top and the bottom, are both 10. So adding those four sides, you get 36. Triangles. Equilateral triangles have 3 equal sides. So the word equilateral, equi means equal and lateral refers to the sides. We have 3 equal sides like this. This one here has side 10. The markings on the sides indicate to the reader that all 3 sides are equal. So the perimeter of that triangle is 10, 10 and 10, or 30. Isosceles triangles have 2 equal sides, such as this one. It has a base of 8 and 2 sides of 15, so its perimeter is 38. And the markings indicate that the sides are equal. A scalene triangle has 3 different sides, so none of them are the same. And to find their perimeter, you must know or be given the information on how long are each of the 3 sides, and you add them. You get 42 for that one there. Right angle triangles we met in the last video. They obey Pythagoras' theorem. So if you are missing one side, such as in this case, you can use Pythagoras' theorem to find the missing side. There you have it. And the missing side is 5. So now we can get the perimeter of this triangle. It's 3, 4 and 5, which add up to 12. Isosceles triangles can be divided up into 2 right-angled triangles. Okay, so, and if you have the vertical or perpendicular height, it is possible to divide it into 2 right-angled triangles, and you could use the height 12 and half the base 5 with Pythagoras' theorem to find that sloped side. And then it is the slope side that you would use in calculating perimeter. Okay. All right, circles. Firstly, the perimeter of circle is also called its circumference. Okay, so the distance around the outside is also called circumference. The formula, so we use a formula for anything circular. The formula to calculate the circumference of a circle is L for perimeter equals 2 pi r. Okay, now this formula can be found in the formula book that is provided to you for your exam. So you do not have to memorize it, but you do have to know where to find it. In this formula, pi, so that Greek letter pi, is roughly equal to 3.14. Okay, we'll speak a little bit about pi in a minute. And r refers to the radius of the circle, which means the distance from the center of the circle to the edge. And in our diagram here, the radius is 5 centimeters. So to calculate the circumference, I would always write down the formula first. Straight away you gain marks by choosing the correct formula. And now let's substitute the correct values. So we have 2 multiplied by pi, which is 3.14, multiplied by 5, which is our radius. And in this case, we get 31.4 centimeters. Okay, just a few notes on pi. Well, pi is something called an irrational number, meaning that it is never ending. There is no pattern to its digits, and it cannot be written as a fraction. Okay. Pi is actually the number you get when you divide a circle's circumference by its diameter. Okay, no matter how big or small the circle is, when you do those divisions, you always get pi. For our purposes, we will use 3.14 usually in calculations, unless otherwise specified. So sometimes you're asked to use 22/7, so it's in fraction form. When the question asks us to do it, we'll do that. If some of the other information in the question is in fraction form, this can be useful. Okay, and if you want to try on your calculator 22 divided by 7, you'll see that it comes out as 3.14 something. Okay, it is again an approximation of pi, not the perfect pi. And we will use pi when the question says in terms of pi. That means if you're asked to give your answer in terms of pi, you don't change its value to 3.14 or 22/7. You leave it as a letter as you would an X or a Y in your answer. Here's an example of that. What is the circumference of the circle below? Give your answer in terms of pi, so it's specified. So it's the same circle from the previous slide. We have the same formula, L equals 2 pi r. But this time we don't change pi, we leave it there. And our radius is 5. So my answer is 10 pi. And it's measured in centimeters. Okay, so when it says in terms of pi, pi appears in your answer. Okay, what about a semicircle or half a circle? Firstly, a diameter is a line through the center of a circle from edge to edge. A diameter is twice the radius of the circle because it goes from the center to the edge 2 times. And we're asked to calculate the perimeter of the semicircle shown below, and we're told to use pi equals 3.14. Okay, so in this case, the only information we're given is a diameter, which is 38. Okay, so from side to side through the center measures 38. So from that, we can take that the radius is half of the diameter, divide by 2, and it's 19. Now, the curved line of our shape here, remember we're going all around the outside, is half of a full circle. So we can use our circle formula, put in for pi, so substitute 3.14 for pi, and 19, not 38, 19 for the radius. And calculate, and that's the answer I get. Okay. But if you're to go all around a semicircle, you have the curved line, but you also have the, oh yes, we have to divide the curved line by 2 because we've only half a circle. That's 59.66 for the curved line. But we also must walk the straight line to complete the perimeter of the semicircle. So it's 59.66 plus 38, giving 97.66 centimetres. If they're measured in centimetres, I shouldn't have put that in there. Okay, there was no mention of centimetres. All right, so as you go on, you get faced with more compound shapes. A compound shape is a few shapes stuck together. What is the perimeter of the shape below? We're asked to give your answer correct to the nearest whole number. Okay, we'll look at that at the end. And remember, we're sticking to the outside of the shape. Okay, so this picture looks kind of like a pencil. We've got a semicircle, a rectangle, and what looks like an isosceles triangle. Okay, so we're just sticking to the outside of the shape. They're the heavy black lines. Okay, we'll take them in stages. So first we're going to calculate the curved line, so the semicircle at the end. It's half of a full circle. Using our circle formula, we substitute for pi, and we use radius equals 3 because that 6 there is a diameter, so half of that is 3. And calculating there, I get 18.84, dividing it by 2 because it's only half a circle, I get 9.42. Okay, next is the rectangle. Well, only 2 of the sides are on the outside. Okay, the 2 black lines that are dark, and they measure 12 each. So 12 on the top and 12 on the bottom. And they give us 24. Next, we looked at a triangle. The 2 sides of the triangle we need to include. Use Pythagoras' theorem to calculate their lengths, because we're not given their lengths. We're given an internal length there. And we have what I would call its base, the dotted line as well. Okay, if we take 1/2 of the triangle, okay, it will measure 10 along the long side and 3, so half the 6 along the short side. Okay, and we use Pythagoras' theorem there. You can see the workings. You can pause it if you wish, and we get the sloped side of the triangle is equal to 10.44. But of course there's 2 of those, so that makes 20.88. So to answer the question we were asked, what is the perimeter of this compound shape? We have to add the individual answers from A, B, and C together. We get 54.3. Okay, returning to the question and the instructions, give your answer correct to the nearest whole number. We'll say the perimeter is roughly equal to 54. Okay. Now, the next example has some missing sides. What is the perimeter of the shape below? Okay, so you can see there's not very much information. Our first step is to fill in the missing sides, and remember, what goes up must come down, and what goes left must go right. Okay, you'll see what I mean in a moment. Firstly, we're going to consider that line 3. Okay, there's a matching line the other side, so I'm going to call that 3 also. Okay, so there are 2 vertical sides. And sticking with the vertical, I know that this side here, the total height of the shape on the left, so what goes up is 18, is equal to the total length of the side of the shape on the right. That must be 18 also. Okay, now let's look at the horizontals. The total width horizontally of the shape is 16, which if you look directly upwards, if we put these 3 horizontal lines together, we don't know what they measure individually, but we do know that together they should measure 16. Okay, so what went right must come back left. Okay, so adding all those numbers together now, so 2 18s, 2 16s, and 2 3s, we get 74. Okay, it's time for you to try some. Do your quiz and your written exercises. And here's a glossary.